All right, let's work on the second problem of the day. This is LeetCode number 91, Decode Ways. A message containing letters from A through Z can be encoded into numbers using the following mapping. A is 1, B is 2, and so on until Z is 26. To decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. For example, 11106 can be mapped to those numbers, and we cannot have any leading or trailing zeros. And of course, we can't have any number that is, or any mapping that is larger than 26. We always, and then our result is the number of ways that we want to decode this. So our input is some string of digits, and our output is the number of ways that the string can be decoded. And this is contingent on some constraints that the number cannot start with 0, or the encoding rather cannot start with 0, because 0, 6 is different from 6 as we were provided. And also the encoding as a number can not be larger than 26 because there are 26 characters that we were given in this mapping. Okay. And the length is 100. So length of string is between 0 and 100, which seems to suggest an O of n squared or s squared algorithm, and we'll see about that. In terms of an O of s squared algorithm, this probably smells like dynamic programming, where if we really wanted to break down this question, I think in any case, the first thing this reminds me of is something like word break. And where word break was like, okay, so we have this set of this giant string, and we see if it can be broken down into our dictionary. And in that case, it was like whether or not our current we could break something into a string, plus whether or not the rest of the string can be broken, right? And so that was a little bit, I guess, like backtracky in a sense, where we said, okay, we'll break it into this word, and then we'll try the rest of the problems. At the same time, I don't really quite remember how word break was solved, so this might be actually a pretty good review of that. Does feel like dynamic programming or some sort of backtracking, something like that, right? Let's see. So we can say that the number of ways that our current problem can be decoded depends on, or is equal to, it is 1, assuming that our current decoding is valid, plus the number of ways that we can decode the rest of the string. Right, so assuming that our method is valid and the rest of the string is valid, then the number of ways that we can decode this will be equal to 1, assuming that ours is valid and the rest is valid, and it's equal to the number of ways that the rest can be decoded, I think. Let me think about this some more. Because it is very important to not sort of overdo the number of ways that we can decode it, right? And what I mean by that is that we certainly don't want to overcount the number of ways that we can decode something. So if something starts with, let's say that our current decoding is valid. Then if we had, let's say, X number of ways to decode the rest of it, then the number of ways that we could decode it is X. It's not 1 plus X, because there is only one way of encoding our current. Let's see. So it seems like there are two things that we can do. We can either see if the next subproblem let me see. So assuming we have 0 items in our decoding, we can take the next number and the number of ways that the rest can be decoded, so n minus 1. Assuming that we have one number in our decoding, we can take the next number if and only if our current number is 0 or 1. Oh no, if our current number is 1, and or 2, and with regards to 2, the next number must be 6. Well, if we're doing backtracking, right, then I suppose that we don't necessarily need to care about this. Because the backtracking idea in my head is that we will take the next number regardless, assuming that we only have one character. And if the number is too large, then we will disregard the rest of this path. And for each step, we will create 2 paths. One in which we take the next number and we just decode it as usual. And another one in the sense that we take the next number as part of our decoding. So we either start over at our current decoding, or take the previous value. Okay. I'm starting to see sort of both, I guess, kind of methods emerging, but I'm still not sure in terms of putting it down as an algorithm. I feel like I'm starting to understand the problem, but let me see if I can like get like a nice example to work on this in my head, and let's see what happens, right? So let's see. Let's start with the first value. And we'll split this up into its own. I mean, an array of size 100 wouldn't be terrible, so we could do that. So we could have each individual one. So this is splitting up characters into their own cell in an array. Then for each, this is the number of ways, so this is the DP array. and each cell represents the number of ways that we can decode up to this string, or this character rather. Of course, in the case of the first cell, the first character, we only have one way to decode it, and that's to just decode the single string. In the next case, we can decode it in two ways. We can either decode it as the first value, or we could decode it on its own always, as long as it is not a 0. And we could decode it as a pair from before, so long as we have the value, so long as we have a valid combination from before, right? So in that case, we can take the pair from before. So we can either decode the number on its own, provided the value is not 0. We can also decode it as a pair based on we can decode it as a pair based on the previous number. So in this case, we have 1, 1. And when you have 1, 1, we can decode it as AA or L, right? K, I think. So we can decode it in two ways. We can decode it as itself, or we can decode it as a pair from before. At the third one, we have, of course, we can decode it on its own, so that's one way. We can decode it as a pair based on its previous number, that's two ways. So now for 1, 1, 1, we can decode it as AA, we can decode it as AL, or we can decode it as LA, right? So in this case, let's see. Perhaps it is, rather this is AAA. So there are three ways of decoding this. Three ways of decoding this, and it's either decoding the value on its own. So what did we have from before? So this 1, 1 was either AA or L, right? Or K, I think it's actually. So what we added was adding it on its own, which is this one, which doesn't change it. So as long as it's not 0, we don't need to modify this. So we know that we have that. And so these two are the bottom ones, are the added ones, really. Well, you added only really one. Okay. Let's continue on to the fourth value. So this can no longer be AAA and then another value. So that one is invalid. We can decode this as either AAJ. We could also decode this as KJ. We could also decode this as is that really the rest, all the values that we can do? Because we could do A, and then J, right? We can do 2 and 2. We can't take this middle one, and we've done that already. So that only gives us 2 options really to do that, right? Interesting. Okay. So if the subproblems is based on whether or not our current mapping is valid, plus the rest of the subproblems, how do we want to tackle that? I was thinking memoization, but I'm not sure if memoization is really going to help us here. Because the number of values from before doesn't seem to really be very helpful, in the sense that it doesn't really matter that much to us, as far as I can see. Though, actually, well, if we take a look at 0, we can't make a pair with the previous one, or we can't make a pair on itself, so we can't just take that. But what if we consider taking a look at the one before it, at the 1 at index 1 right here, and the value and the number of pairs there. So there are 2 ways to break it down into that previous one, and there's only one way to break it down in this case. And let's take a look at this. Well, there is one way to break it down with our previous, or rather, there's a new way to break it down with our, to include our previous value. But adding this makes it tricky. When it comes to 6, we could break it down on its own, and we can break it down based on the number of ways that we can break down the previous. Well, previously, if we only had 1110, we only had two ways of breaking it down, right? Either AAJ or KJ. And yeah, okay. So there's one additional, or there's one way to break it down. We can't break it down with the previous. So the number of values here is 2 as well. But what is that dependent on? Really? That's the number of ways that we can break it down in the previous way, and the number of ways that we can break it down in the even more previous way, as long as this is valid. Okay. Is it though? So it's the maximum of number of ways we can break down the string in n minus 1, number of ways we can break down the string in n minus 2, but this is only if valid, and is also only if valid. Else, well, would there ever be a case where both are invalid? Well, I would assume not, assuming that I assume that there is always a valid way of breaking down a number. Yeah, I think so. But when do we add the +1, right? Where does that +1 come from? Let's see. Where does that +1 come from? Well, if we had a 1, and now we added a 1, 1, we have one way of going on our own. Maybe it's actually the sum. Because if we had something like 1, 1, 1, 1, right? We could get 4 A's. We could get AAJ. We could get AJA. We can get JAA. We could get JJ. Yeah, so it seems like it's the sum of both as long as they're valid. So since this is not valid on its own, right? Because this value is a 0, then this is 0. And the ways that we can break it down if we take the pair starts from here, which is 2. So therefore this is 2. Subsequently, if we start with the number of ways that we can break it down, so for example here, the first number, as long as it's non-zero, will start as 1. And the number of ways that we can break things down in, if we took both, will also start as 1. Because in both of these cases, if there is an invalid index and the previous number is valid, then that means that there is only one way to create that number, and that number happens to be just on its own. However, this is exactly equal to -1. Actually, no. This exactly -1. Because in this case, since there is no number before it, it cannot pair with any other number, and therefore it cannot form a valid pair, and therefore there is no valid ordering for that for us to use. So that should be only if n-2 is exactly equal to -1. I think this is all right. I'm just very curious as to whether or not this will work. Actually, now that I see this, looks like maybe we have a corner case here where if it leads with 0 ways, because 0 cannot exist on its own without a pair. Okay. I don't think that applies to any, yeah, that does not apply to any other number. Okay. I think that makes sense. And in terms of runtime, I think this is O of n runtime and O of n space. We could use S, but is the length of the string. Technically O of 2n space, because we need to also store the dynamic programming. And this is like sort of bottom-up dynamic programming. O of n time, because we only really go through the array once, or the string once. Well, twice if you count the initial splitting. So actually we can say if s.length is equal to 1, then if s at 0 is equal to 0, return 0, else return 1. This is just sort of like basic. Actually, let's see. So we know that the length is greater than 0. So we can just actually, if s at 0 is equal to 0, return 0. And then here, if s.length is equal to 1, return 1. The idea really being that if we know that it's a non-zero because we had the case before it. We know that there is a length of 1, and therefore in that case, it can be any, there's only one way to decode it, and that's using the single digits. Then we can say val character, or actually, I think we could actually store this in single linear time. dp list or dp array is going to be equal to s dot, or int, is it going to be an int array? Yes, an int array of size s dot length, initialized to 0. And then dp array, and we can say s dot for each indexed. And we can say, let's see. We want to say decode as self will be equal to if character is not 0, because we can't decode it as itself if it's 0. Else 0. If the character is not 0, then if index minus 1 is less than 0, then return 1. Otherwise, it is dp array at index minus 1. And decode as pair. If the character, let's see. Well, we really want to check, right? We want to check to see if what are the restrictions on this? If the previous character is 1 or 2, is greater than 0, else if index minus 2 is exactly negative 1, otherwise 0. So this is 1 if it is actually, is it? Only if it's valid. Okay. So I guess we could just get rid of this entirely. Or index minus 2 is exactly, well, minus 1 is greater than or equal to 0. So as long as we have a previous character to try, then we can say val pair is equal to integer.parseInt. We want a string that is composed of our s at index plus s at index minus 1. And if the pair is less than or equal to 26, then we're good. And index minus and our dp at index minus 1, or not dp, or is not 0. We can't have 0 as our previous pair value, right? So in that case, we want to check and we want to see that as long as the pair is under 26, then we're fine. As long as when it's parsed into an integer that we can do that, then we can do dp of index minus and dp or index minus 2 is greater than 0. Otherwise, this is just 1. Or if pair is greater than 26, then 0. This is a little bit weird because we're dealing with let's see. Maybe a when is better. Pair is greater than 26, then we just return 0. And in the case that 26 or the pair is not greater than 26, then we want to make sure that if the index minus 2 is less than 0, it's exactly equal to, actually no, we're fine. It's less than 0, then it's 1. And otherwise it's dp of index minus 2. And then we want to just return dp array at s length minus 1. No, I wanted to do that. Okay. Attempt to do so. I'm not sure of this string, if that's kosher. Let's see if that's kosher in Kotlin. We can just construct a string like that. Could probably actually do like this. This is a really weird way of doing this, I will admit, but it should work. Don't need that. So again, the idea is that we go through each character within the string, and we'll check if, first of all, we see if we can decode it by itself. If we can decode it by itself, which means that it's not 0, otherwise it's just 0 on its own. We can't decode it by itself, and we shouldn't even evaluate the previous. If it is non-zero, then we check to see if there is a previous value of the number of ways that we can decode it. If there is a previous number of ways that we can decode it, then we use that value. Otherwise, we use 1, because there is one way to decode it on its own without anything else. However, if there is a previous, then there is a, let's say that there's only one way to decode something on its own. Like, let's say that, well, there's no actually item that where it can only be decoded on its own, now that I think about it. Well, actually, no. We can use the example of the 6 here, right? The 6 here, and there's only one way to decode it, or there's only the way to decode it on its own, and that is based on, okay, we can decode it in one way, and then we can decode the previous string in all these other ways. But since there's only one way to decode a single character like this, so we do it like that. If there is a way to also decode it as a pair, then we also include it in the number of ways that we can decode. And then at the end, what we want to do is that we want to say dp array at index is equal to decode as self plus decode as pair. This is a little bit weird, but I'm just trying to think of how I want to explain it in a way that makes sense to myself as well as makes sense to y'all. If we have a way that we can decode it as on its own, and a way that we can decode it as a pair, then the number of paths that we can take is that we can take all the ways that we can decode the previous values, plus decoding it on its own, and we can also do all the ways that we can decode it previously before the pair, and the ways that we can decode the pair. And yeah, so let's do a bit of a trial run. Just on this one first. So on this one, decode as self, character is not 0. Characters minus index minus 1 is less than 0, so that's 1. Decode as pair, index minus 1 is not greater than 0, so we skip this entirely. And so this is set as 1. The next one, well, we can decode it as itself, right? Because it's not 0. So this is set to 1. Decode as self is set to 1. Decode as pair, well, index minus 1 is not 0, and it's and the last value is not, the previous value is not 0. Then we evaluate the pair. This is 11, which is less than 26, so this doesn't trigger. However, the index before is minus 2 is less than 0, so there's only one way to decode it. So therefore, this is also 1. So now we have 1 plus 1, so that's set to 2. In the third one case, well, we can decode it as itself, right, as per usual, but this time there are 2 ways of decoding the previous string, and then we just include the one on its own. Then we can also decode the previous as a pair because the last value it's not at index 0, and the previous value is not a 0 either. The pair is 11, which is less than 26, and so we take the number of ways that we can decode the previous before the pair, which is only one way. So now we have 2 plus 1, and that's 3. The 0, well, we can't decode it as itself, so this is 0. But we can decode it as a pair. And the way that we decode it as a pair is that we take this previously, so we combine it, so that's a 10. This is less than 26. Index minus 2 is not less than 0. And so we can only decode this as a pair, and the number of ways to decode the previous before the pair is 2. Now that I'm speaking out loud about this, I just realized that maybe there is another corner case where we can actually terminate the algorithm early if we see a pair of 2's within our string. Because if we see a pair of 2's within our string, we can't process them both as individuals because there's no value as a 0. And we can't process them as a pair either. So if we see a pair of 0's, there is no way to actually decode them. So in that case, we can say if dp array at index happens to still be 0 after we've added it, then we can just return 0. So this is a very, very small optimization if we see a pair of 0's. Continuing on, so now we see the 6. We can decode the 6 on its own, right? And because it's not 0, so the previous value, we take that, and that's a 2. But we cannot decode this as a pair because the previous value is a 0. So this is set to 0, and so we do 2 plus 0, which is 2. And then we ultimately return 2. Okay. We've also accounted for the fact that we can't start with the 0. Let's try 2, 2, 6. 2 starts on its own as 1. This starts as 1 because it's a non-zero character. There's no other characters before it to decode as a pair. And so this just starts as 1. This second 2, it can start on its own. So we can take this. This can also be a pair as 22. So now we have 1 plus 1, which is 2. And then this 6 can be decoded on its own. So it can be decoded in 2 ways plus the 6. And it can also be decoded in 1 way plus the 26. So that's 3. And we return 3, and that's correct. Okay, this seems to be correct. Let's go ahead and run this and make sure that we don't run into any compiler errors as well. Let's go ahead and run through the entire test suite gamut. Looks like we hit an error here. Actually with 226. Let's see. So it looks like 226 is not working, interestingly enough. Let's go ahead and take a look at why this isn't working. It's reporting 2 rather than 3, which is interesting. It's not hitting there. Not hitting. Index minus 2 should be 1. Character is not 0. Very, very interesting. Let me print this as a pair. And I'm going to print this out. And let's see where this takes us. Ah, I did this backwards. That might explain it. Okay. So now this should be 3. Excellent. Let's go ahead and run this again. And let's do 11106 just to test out this one. And we can also test our little edge case in the middle where we have a pair of zeros, which should return 0. Cool. Let's give it a submit and let's see where we end up. Let's see if there are any other edge cases or maybe our algorithm is still incorrect. Looks like it works. Awesome, awesome, awesome. So, dynamic programming, it's a thing. I'm glad that I eventually worked it out. It started off looking maybe like a little bit backtracky, but I kind of went dynamic programming based on the fact that generally when it comes to problems like this, like I think that there is some value that usually is reused from previous subproblems, and that's how you actually achieve the proper runtime. But I'm sure that, and I've heard it somewhere, that dynamic programming and backtracking are very, very similar problems. And I'm sure that to a certain extent you could probably do something in terms of backtracking with this problem. And that could be probably a valid solution as well. But in this case, I feel maybe I just have a bias towards dynamic programming because I've been doing it for a while now, more than backtracking. But in any case, the core idea is this, that in any character, given any character, we can either choose, as long as it's valid, to have it be on its own, decoded on its own, or we can choose to have, as also if it's valid, decoded as part of a pair with a previous value. And in this case, If it can be decoded on its own, then the number of ways that it can be decoded is the number of ways that the previous string can be decoded. And if it can be decoded as a pair, the number of ways that it can be decoded also includes the number of ways that it can be decoded before the pair. We add those up because both of those number of ways to decode before we add our individual new items is valid. And then at the end, we return basically the result at the end. So this is, I guess you would call it bottom-up dynamic programming, because we're building from sort of nothing and then we're building up to our solution rather than top-down recursion. Maybe I'm getting my terms mixed up. But the core idea is just the number of paths and the number of ways to decode it. I'm still a little bit tripped up by these types of problems in general. Like for example, path sum 3. I remember cracking my head against that one for a while, right? Path sum 3, because you just didn't add the number of paths. The number of paths that you had available in there, if you go through a node, is the number of paths that you still have and that you build up upon, right? You don't add another path just because you go through this node. The number of paths that added up to a particular number can go through this node and all of those nodes can add up to the same amount. I think it's a very similar situation here, where if you go through and add this particular character, you take all the number of ways that you can decode the previous string before arriving at this character, but you also have the additional idea of we could also be coming from all the ways that we could decode the previous string before coming to this pair, as long as, of course, those ideas are valid. The pair or the character is valid. So that's the gist of this problem, using dynamic programming. Not a particularly fast submission, but I think it's a pretty average submission. I'll definitely take a look at the discussion page after this. But in any case, I hope you learned something, and I'll see you for the next problem.